Hi everyone. Today I want to introduce the multimedia security, which is different with the content of the text area. Uh, in our homework 2 and the midterm project, we focus on the text area and how to apply the differential privacy on the text domain. But uh, from now to the final project, we will put more focus on the multimedia area, as for example, the how to apply the differential privacy or other privacy protection skill on the image or even the video, this kind of multimedia area. And today I want to introduce the face de-identification. Mm, as you know, the Google's Street View, they will use face blurring here to protect the privacy. However, in the Google's system, this privacy protection is not so enough in some scenario. A special for example, in this news, uh, uh, there is a criminal from the Italy, and and the police and try to catch him. Uh, Finally, they find this criminal from the Google Street View because the face blurring is not so enough, and they find this criminal. And also, the privacy because of the privacy issue of this Google's Street View system, and Google's agreed to pay a lot of money for this case, for this kind of case. So, in today's introduction, I want to introduce the basics of the burning and pixelization, and I will continue to discuss the potential security issue they pose. And finally, we will explore how to enhance the privacy by the differential privacy method. So this is outline for today's discussion. Uh, in the Google Street View, and we this system will do the face burning for the humans, and how to blur a face. And I want to introduce the basic. In the first step, we will read an image like this, and then we will do detect face, which is which and where is the face, and then we will draw a rectangle on this detected face, uh, and we will call it ROI. It means the region of interest. And then we will blur the rectangle like this. And finally, we will display the output image. So this is the workflow of how to blur a face. And then we will introduce one by one for each step. When we finish the reading and image, we will do detect face. And there are a lot of kind to detect face. Uh, you can do this kind of hard case, and or you can combine the HOG and the linear SVM, and you can use the machine learning based face detector. And you can read more about the face detectors for these two blog like this. We can know more about this. In this article, you can read a lot of you can read a lot of content, how to do the face detection. And you can see, but because the face detection is not the main focus of our class, so I will not go so deep. And you can call the library from the Python or many library to do the face detection. But if you want to know the idea of the face detection, you can read this blog, this article. And I think the basic idea is for the original image, we will do the crop and the resize, and then we will calculate the image. And then we will try to find where is the face. And yeah, like this, we will try to calculate histogram. And then we will find this kind of gradient and try to find the face. Okay, so I think you can go deep for this, how to do the face detection. And if you want to want to go so deep, you can just code the library like this. In in the CB2, you can just call the face detection like this kind of code. So it's so okay. Okay, so I just mentioned there are many kind of uh, face detector you can use nowadays. And then you can draw a rectangle on the detected face to extract the ROI. And in this rectangle, your face detector should provide you the boundary for this face, the position of x and y, and you can use the information to extract the face ROI itself. Like this, you will just extract this face like this, and then is to blur this rectangle, and there are two kind of basic skin. The first is to apply the Gaussian Gaussian blur to analyze this face. And the second one is to apply the pixelization method. And for the first one, we will try to apply the Gaussian blur skin. And here is just similar with the general Gaussian function and in one dimension. And in two dimensions domain, the equation is like this. And by this function, you can do the Gaussian blur like this. This is the original image, and it is the blur image using Gaussian blur with the parameters being 2. Okay, so so this is the whole workflow for how to blur a face. And I also provide the whole the code, and if we want to make some reference, you can just check the code here, and it is the whole content of this text. And then we will want to discuss how to do it more efficiently. For example, in many images, you should in some case maybe you have a lot of face in the same image. So how to do the the blurring for all the face? It should be a difficult text, like Google's Street View. They are they sometimes they should have many face in same image. So how to do it more efficiently is very important. And so try to do it face is the first principle. And how can we do it? Uh, we can one of skin is we can do sprinting for the image like this. This is the original image, and then we can do the split this image into four sub image, and then we just apply the this uh, workflow of the face burning on the full sub image, and then to reassemble them back together like this. And and another point, maybe you can apply the better machine learning method. uh, Today's there are a lot of model. Uh, there are a lot of pre-trained model. They have which be trained on a very large database. So for this kind of model, it can help you to do better face burning text. And also in some case you may need to find a small face uh, like this. It's a normal image, and in some image the face is very small in this kind of in this image. So, so you need to for this kind of case, maybe uh you need to apply the library or tools to help you to complete the text, how to detect the face. Like for example, the Google's NLKit, that it can find a very small face, and you should have a lot of GPU and memory to help you complete the text. And to the say to the burning because uh the 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 skin I have introduced is how to better detect the face, and then I want to introduce how to better blur the face. For the burning phase, uh, some skins should be like you can you can apply the mix in the image like this, and in some cases it may help you to uh make make the burning better if the precision is better. However, the more complex the mix, um, you have, the longer it will take, the longer time it will take to process. And the land you can, uh, you can try to cut off all the face, and then put land in one row like this, and you can just do the burning, the image in this row for whole images, and then put them back to the original image. So by this method, you can get all the blur face at the same time. And another schemes is, you can try to blur the whole image at the same time, and then cut out the blurred face, and put them back to the original image. So this is another kind of scheme to blur, many image at the same time. And for the other method they, for some method they may apply the more flexible skin. They may try to layer argon will maybe maybe they will divide by the small face, medium face, and the big face. Like this is a big face, it is a medium face, and it is a small face. And they will divide all these kind of face into three group. Uh, Firstly, I mean, at the first step, and then they will use the different uh, radius value for burning the original photo in this group. I mean, you may apply the different degree of burning in these different size of face, and then you can put them back in the original image. And sometimes if you apply the different degree of the burn uh, skin, it may help you to do better the face burning. Okay, so the next is, I will introduce how to apply the pixelization skin, and how to create a pixelate face bird like this. You It is not just blur like this, and like now we hope we can get a pixelization results like this. There are a lot of cell in there are a lot of grid in the face. So the whole workflow is similar with the face burning. The only difference here is, uh, when we do the blur rectangle, we will try to apply the pixelization method to pixelate the face. So the idea is very easy. When we want to create a pixelate face blur, we can just for this we can focus on this rectangle, and then we just divide it into the n by n blocks like this, and then For each blocks, we will calculate the mean value, the mean RGB value for this block, and then we replace the original value by this mean value. So finally, you will see the results is like this, the pixelization results. Okay, so this is the most basic idea of face blur, and we can do the uh, face blur and the pixelization. And then I will continue to introduce the security issue, the secure vulnerability of this kind of system. And now we will try to take this kind of system. We will try to prove this kind of face blur or face pixelization system is not so safe. It's not so secure as you thought. We can apply the AI or machine learning method to predict the original image. So now we will try to do this. And for the attacking step, the adversary will try to get a set of a plan and on blurred image of the target people, and then when we get this plan image, we will try to on purpose blur this image by the adversary himself. And the easiest way is we can just request the YouTube video manager to blur the face, or you can do it by your own code. And in your homework, I will require you to do this blur by your own code. And then now, when you do the blur for uh, this plain image, you should get many pairs of the plain and blur images. And then you can just perform a supervised machine learning on this kind of blur image, because you have the plain image first, so it can be your label, and you can know which also no because you have no the plain image, so you should have the label, which will uh, point which people own this image. And I mean, uh, the label will mention this face is of which people, or of which person. Okay, so you can just perform the supervised machine learning on this plain bird image. So when you finish the training, your machine learning system it can predict the original image from the pixelization or blurred face image. Okay, so in our homework, I have provided some paper mention this idea, and this is one of the results of these papers. And you can prepare the data set like the NNI STO cipher 10 or AT&T like this, and you can know the which yeah, you can get the face, and then you do the burning on purpose by yourself to get the burn re- result, and then and then you just do the training for your example for the result. You train the machine learning to establish the relationship between the two images. And when you finish the training, this AI, this machine learning system, when it see this kind of face, they can predict uh, this blur image should be of this guy, like uh, like this. And according the paper's content, you may get a uh very higher currency of the this kind of taking action. Like this, you may get a very high result. So it is your homework one part of your homework three. And then for this AI induced security vulnerability, this kind of attack, we want to develop some defense method for against this attack. And now I want to introduce the defense method based on based on differential privacy. The main idea is like this. Uh, we can apply the differential privacy in the original pixelization of blood face. We 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 apply more noise on the origin on this. We try to apply more noise on the pixelization of blood face image. We apply more, uh, and then this uh, this image based on differential privacy, it will make the machine learning system hard to predict uh, the the original image. And then the next question is, if you are familiar with the differential privacy theorem, you will know the differential privacy is applied only on the function and not on the data set. Uh, I mean, when I introduce the differential privacy, I've said the differential privacy is applied only on I would say the differential privacy is only applied on the function. It's only applied on function like this. Sorry. Differential privacy is sorry. Differential privacy is oh, why? Differential privacy is applied only on the function or computation. This kind of action is not applied on the data itself. And for solving this kind of issue in our homework too, you have try to you should know how to solve this issue. We can we can do another action like this. So we can do another action like this. It should be the true input. True input. It should be the true input. True input. Sorry, it's hard to write or draw the word. It is a true input. And then we just apply the differential privacy here. And then, oh, sorry. And then we will get, oh, I don't know why. And then we will get the fake image. You get the fake image. So, you should know how to do it in your homework too. For this workflow. So by this way, this fake input data is also satisfy the differential privacy. Okay, so when we back to our course, for how to get the differential privacy content, because as we have mentioned, the differential privacy is not just apply on a data issue, apply on a function. So we can apply the idea similar with our homework too. We can apply our differential privacy, combine it with the pixelization of Facebook function. We can apply the differential privacy on the pixelization image, and then we will get the results. And this image should be have the property of the differential privacy, and then it can make the attacking system hard to predict the the original image. Okay, so I have provided some reference paper for this idea. Okay, so so for the real world case, this is the image, and then if we apply the differential privacy, it should be the result like this. Okay, so how can we do the differential privacy for image? Uh, there are a lot of there are many kind of scheme to do the similar action like this, and I have provide one of these papers in our homework 3, and this is the paper, and these papers introduce we can define another parameters and what does it mean? Because in this paper, this paper, which paper? It should be a paper. This paper is yeah. If we follow with the idea of this paper, it will try to uh define another parameter and what's the meaning. Uh, the author of this paper will it's she observed the object in the image. What is the difference for the two image? How can we define the difference? For example, in this image, uh, we should define the neighbor of the input in in the differential privacy. The what is the neighbor is when we when we when we introduce the the basic idea of differential privacy. I have I have said we have the data set X, and we also have a, data set is very similar with data set X. We call it X prime, and the X and the X prime may differ by only one data record. So X prime is a neighbor of the data set X, data set X. Also we also want to define what is a neighbor here. And the author of the paper, they find they she after the difference of the two similar image. They find for example, we when we take it as example, the only difference is there is a more one more person here in this image, and there are no image in the same place here. So for the author of this paper, she said we should just make the difference for this object, this this man. So the total number of pixel of this man, uh, the author of this paper call is n pixel. This means for in this image, this man's pixel may be the uh three 306% and 16% for this man, and so the n should be the 360 pixel in this image. And for another image like this, it's just a face, and the author said it should be the n the n parameter should be just one 100 and one hundred 20 pixel here, 120 pixel here, because if we only focus on the eyes, and maybe in this phase it should be have this kind of eyes, and in different image this guy maybe it have a different kind of the I must say maybe we are doing the research of de- try to detect this man is happy, or it maybe or it is sad, or or he's in the mad mood. So we should have a different kind of eyes for the same guy. And for this kind of case, uh, the n should be specified to the 120 pixel here. We just we just care about this area, and this is our object. We want to put the main focus. So this is n pixel here. So okay, when we have the definition of when we uh, define the n value, we can apply this value to the definition of the sensitivity in this differential privacy system. Because as you note in when we introduce the differential privacy, I've said the main the main key factor you should care about is you should define the sensitivity. You should define the sensitivity delta F because the epsilon you can control it should be a bigger or small, and the f of x is your original function like your machine learning algorithm. So the only key factor, the critical key factor you should define is the delta f, the sensitivity, the the basic unit for the two neighbors. So here we want to define the sensitivity, and by the help of the definition of the n parameter, we can provide the sensitivity definition like this for the pixelization image. Uh, for the each B by B grid cell, we can uh, specify the, the sensitivity like this. Why we use the 255? It, it is because for it is because for the uh, for the RGB value, we can see the original paper. Let me see it. Sorry, where is the original paper? Okay. Oh, mm, wait for. When we read the original paper by this author, we can he said when we after the RGB value, we can note you should be located on between the 0 and 255, and so we can use this range as the we can use it as the sensitivity. We just multiply the n with 255, and we also consider the size of the grid cell, like this. So the pixelization image, we can use the sensitivity like this. And for the blur image, uh, we don't have this kind of grid cell. So in our sensitivity, we should have no uh, no b these parameters in the sensitivity, and uh, it should be have this kind of format. Okay, so now we in this paper they just define the the definition of sensitivity for pixelization and the blur image. And then we can just apply the differential privacy on the face image. And it is your original face image, and just uh, we can just use different parameters of differential privacy here for the pixelization uh, phase for B to D. We can use the different B value. what is the B value? It is like this. It is the different size of the grid cell. You can see it. It is B is a small b, like this is a small unit of the grid cell, like this, and it is have a bigger grid cells like this, and it is bigger, more bigger grid cells, so it should be become this. And for the blur, face blur skin, here we can use the different K parameters of the Gaussian skin here. And with if we have a higher K parameters value, and you can see the 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 effect of the blur, the effect of the blurring should be bigger. It should have a higher impact on the original image. Okay, so this is for the transitional blur and the pixelization result is like this. And in this page, we have not considered the differential privacy, and we will say the if we have no differential privacy and we just use the transitional blur and the pixelization schemes like this, it should be easier to be attacked by the AI, the machine learning method. It can just easier to predict the original image. Okay, so now we will not try to improve the traditional blur and the pixelization method. We will try to uh, add. We will try to apply differential privacy here uh, for these images, for these blur and pixelization method. We can see this row is the original image or original face image, and the NP pixelization, it means no differential privacy, and it is the traditional pixelization method. So you can see the face will become these results, just a traditional pixelization results. And then if we try to apply the differential privacy on this result, we will get the result. We will get the content like this. And also for this case, we will generate the differential privacy result the from this case like this kind of content. Okay, and in on the other hand, for the blurring skins, the MP blur it means we don't have the we don't have differential privacy here. So it's just uh have the traditional blur skin here. It will become like this. And then if we want to improve the traditional blur skin, we can apply the differential privacy here. So it will turn to be this kind of content with differential privacy protection like this. Okay, and then just apply, uh, we just repeat the taking, taking from the from this from this from this machine learning machine learning uh machine learning based tech, and then uh, and then we will just compare the results. For this, under the machine learning based attack, the NP pixelization it means we don't apply the we don't have the differential privacy protection here, and we can see uh, the uh, the machine learning based attack will have a very high successful attacking results. It will get a very high accuracy to to predict predict the result. And if we try to apply the differential privacy here, you can see it drove it have a very dramatic drop from this very high successful currency to a very low value. It means the differential privacy uh, theory is truly it can truly protect the privacy against the machine learning based system. So you can see the the currency will become very low because the protection of the differential privacy. And this is for the pixelization method. And for the burning phase, it is the NP blur. It means no differential privacy. So you can also see it get the machine learning based attack is also have a very high uh, currency result. But when we apply the differential privacy protection, uh, the currency will tend to be very low. So it means the differential privacy protection is just uh, can lower the result of this machine learning based attack. Okay, you can do you can just try it by yourself. It's provide the it's provided by the author of the paper. You can just see this is a original image, and then you can just choose apply the differential privacy based pixelation, and then we can see the result. It is the original image, and it is the traditional pixelization result, and this is the differential privacy based result. And you can also try different case like this, and we also choose this DP pixel, and we can choose the different size of the pixelation. Maybe we can use a small grid cell like this. Okay, we can just try. Just try. You can see it. For the origin, this is original input in image, and because we use a very small grid cell, so the pixelization results is like this. It has a very low privacy protection. But if we apply the differential privacy here, you can see it's tend to be this kind of result. You can also just the compare it with the different B the size of B like this. Yeah, you can see the original input will become the different uh, pixelization results because we use a bigger grid cell. So you can see it's become like this. You can use just median uh, b value, and we see the results. Sorry, here. So you can see it just have this kind of result, and it is a differential privacy result. And then we also, okay, also differential privacy. Okay, and in this in this example, uh, web page, they also try to apply the machine learning based re-identification attack. It can guess uh, which which man is the owner of the face image, and it says uh, this ID it has a uh, higher level uh, of the these pixelations result, and this also sorry it is for input image. We can just guess uh, the input image and is of which person, so it should be correct for the result. And then for the differential privacy image, for differential privacy image, we can see the machine learning based attacking system it cannot successful to recognize or to predict the the image is from which which ones. So you can see it the result is wrong. Is wrong because the truth answer is this man. But if we apply the differential privacy here, you can see the machine learning based system cannot successful to predict or to recognize the original user. And you can try the another people like this. You can just change, and you can also use a different hand like this. So this is and this is a result. This is a result. Okay, you can just try it by yourself. Okay, so for our homework, this week I also provide a homework, and the content the content is just is the progress of this week. Uh, we I hope you can uh do it by yourself for the face the identification, for example, the pixelation or blurring of the face, and then I want to uh, I hope you can try the attacking and the defending for these face the identification system, and I will pro uh, one by one step uh, introduction for this homework. In step one, I hope you can establish a face the identification system, and I hope you should try the burning and the pixelization. Both methods you should do in your homework, and you can just read this resource, and then I want to uh, try to make a machine learning system to predict the to predict the the face image's owner from the pixelization or burning or burning image. I hope you can do the predict for taking. And I also provide the paper describing how to do the take. And then I hope you can try to defend against both the AI machine learning based attack, and you should apply the differential privacy scheme here, and you can make the machine learning based attack system how to predict the which is the owner of the face image. And I also provide the paper. You can just check it by yourself, and uh, you may try to do this defense with or without retraining uh, the original model. I mean, uh, you can just you can you can propose the scenario is uh, you just initially uh, the system, the face identification system, the from the original input image to generate the pixelation results or burning results. You can just in this step you can just apply the differential privacy scheme. I mean, you can do you can do it with retraining the whole model, or you can just do it without retraining, and you just apply the differential privacy content for the data sample, and you can also try it. So it is not limited with for the data is with or without retraining the whole model. Okay, so for your homework, I hope you can have this kind of output. You can check the paper I provide here, and I hope you can similar results. For example, for the step two is a tech, a tech based on machine learning. I hope you can provide. So sorry, I should start from step one. For the step one is I hope you can make the face identification, and you should provide the results both from the burning and the pixelation. So for the first step, you should provide the results of the burning or and uh, the results from uh, 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 the result from pixelation and the result from burning. I hope you can provide the two results in step one. And in step two, I hope you can provide this kind of com- comparison. You should compare. You should compare the machine learning based attack for the pixelations, uh, face image and the burning face image, and you should compare. For example, for the pixelations phase, you should compare the results with different grid cell size, like this. You should compare the result of different grid size uh, here, and you can compare the one 2 by 2 or 4 by 4 the grid size grid cell, and you should also compare the different k parameters in the Gaussian burn-in method, and you should test your machine learning based attack for the different condition, what what the results for these conditions. And for the step three, you should apply the differential privacy, and you in your results you should compare the 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 results with the different without differential privacy, and with the differential privacy you can compare, you should compare all of these, like this table. Okay, so uh, when for your results, you should have a similar trend for the results. When you have a smaller epsilon, it means you add more noise on your data. So you should have a bigger difference between the between the traditional result and the differential privacy result, like this. And if we have a larger epsilon, it means we add less noise on the system, and we should have a similar results for the 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 pixelization with differential privacy and without differential privacy here. Okay, so this is a possible result for the step, from step one, step two to step three, and then finally I require you to upload the detailed report to Moodle. Similar to the homework tool, you should provide your code and your report file, and should include a table in your report to outline the responsibility of each team member for this homework. And then you just zip this file into one, and then upload the file to the Moodle website. Okay, so and okay, so I will provide the daylight in Moodle. I think you should have the 2 more weeks to complete this homework. Okay, so this is the teaching content of this week.